Hello guys, I'm Malikosha Enoch and welcome to my math tutorial session on probability and statistics. Okay, and this is actually Cambridge Advanced Level Mathematics paper 6 probability and statistics. That is 1S1 and that is paper 6-1. Okay, so this is actually May June 2018. So I'll be solving all problems. Okay, guys, so I'll be solving all problems in May June 2018. Let's get started with the first question. In the statistics lesson, 12 people were asked to think of a number x between 1 and 20 inclusive. From the results, Tom found that the summation of x is 186 and that the standard deviation of x is 4.5. Assuming that Tom's calculations are correct, find the value of summation x minus 10 and summation x minus 10 squared. Okay guys, don't forget that this type of question, this has to do with measure of location and spread. So if you recall, this one is like you take away 10 from the set of data set. So this type of question now, we such that you want to make the main calculation easier. So for example, we have data 95, 96, 97. So you take away 90, then you find the mean of the remaining one, then you have to add it back. So let me quickly give you the formula to that effect. So if you have something like that, let me just put it in a rectangular box. Sorry about that. Okay, so let me just make it a little bit bigger and put my formula there. So I think everything is clear now. So mean, okay, equals to summation of the all observation I is a counter, minus a constant, okay, then you have to add a constant back, plus a, then over n. Okay, so let's go ahead and work with this now. Okay, so now the first thing I would like to do here is to go ahead and find the mean. Okay, so don't forget what is mean. Mean is that is generally, so mean is summation of all observations, okay, divided by the total number of observation altogether divided by n. Okay, so now if you look at it, this one now, so you can, because that's something we have here now. So if you come back here, we have 12. Okay people, and the summation of x is 186. So that is 186 over 12. 186, that is sum of all observation, that is 186. Okay, and there are 12 all together, or samples. So what is that? So let me take my calculator and do that now. So 186 divided by 12, so that is 31 over 2, that is 15.5. So this one here is 15.5. So this is the mean here. Okay, 15.5. Okay, but guys, what we are asked to find is this here. So this one here. Okay, a is 10. So a is 10 now. So I can go ahead and rewrite my formula now. So I'm going to put this one on the left hand side, since this one I'm looking for. Then to make that subject of formula. So summation x minus a is 10, 10. Okay, so minus 10. So mean that from each observation you take away 10 before you compute your mean. So that's what this is saying. Okay, divided by n. So your observation altogether we have 12. Okay, equals plus, sorry, plus in order not to waste much time and to manage my board very well. So if you move a here, that would be by x minus a. Don't forget where a is 10. Let me just put this one here. A is 10. Okay, from here. So therefore I'm going to have, and I have my mean here, so you're going to have mean plus by x plus a. So sorry, by x minus a. So that would be 15.5. This is video, guys, hope you are following. So 15.5, okay, minus 10. So that's what we're going to have there. So then make this one subject of formula now. So that would be can I manage this board very well, guys? Let me just go ahead and demarcate this. Sorry about that. Let me just go ahead so that I'll be able to solve maybe some other problems here. Okay, so let me see if I can complete everything here now. So summation x minus 10. This is actually observations, okay, like xi. So but just let's have it the way it is. Okay, equals to, Okay, it's 15.5 minus 10, that's 5.5. 5.5 times 12, 5.5 times 12. So that is 66. So that should be the solution to the first question. Okay, guys, this is 66. Hope I'm calm enough, right? So that you can understand what we are doing. So let me put that one in a rectangular box, guys. Okay, because this is additional mathematics. Sorry, this is advanced level mathematics, Cambridge. Okay, so some of you guys take P1, P2, okay, P3, S1, S2, then M1, M2. Okay, guys, this is S1. So that's the solution to the first question, guys. So let's go ahead and compute the solution to the second one. Now this one, if you look at this one here, this definitely will be from variance. Okay, because this is variance summation x squared, something like that. So you just take just like you are trying to compute the mean first. So it's just something of this nature. So I don't know, should I just go ahead and put the formula also in rectangular box, guys? Doesn't mean I'm giving you Haluko just like giving this own formula. It's not my own formula. Okay, I'm going to show you. Okay, by the time I solve like two or more questions, then I'll try to take my time and explain how you can actually derive all this from the conventional formula you are familiar with. Okay, so yeah, let's just go ahead now. Now don't forget that variance, and now since I'm going to take away a constant value from each one, then you just, as though you want to write your conventional variance, and that's what I'm going to use. Then I will show you how come about my formula, guys. Okay, so let's get started now. Now don't forget that in variance we have summation. Let me just put, I don't know the symbol, should I, can I use s square for my sample variance? Let's use sample variance. Okay, now let us use population variance, s square. If you want to use population variance, that would be like sigma square, something like that. But I think just go ahead and sample variance is okay for us. So it's sample of 12. Okay, so sample variance so equals to summation. Normally conventionally you should have summation x squared. Okay, summation x squared. Now you are taking away 10 from each observation, so something like that. So summation, okay, so take away the 10 like that. That's the same thing. That's what I, this one also summation x over n, so you are taking away, then you add it back, so something like that. Okay, summation x squared over n, right? So now summation x squared, so you don't have just summation x squared, you just have summation x minus 10. So x is x minus 10, that's okay, so something like that. So that's how I come about this. Minus summation x all square, that's what I supposed to have here, summation x then all square, like all square here. So then, but you are taking away 10 from your from each sample too, so you just do minus 10 like that. So do you understand this now? Then over n, so just from your conventional formula. So that's how I come about this. Sorry about that. So that's how I come about this, guys. So you can go ahead and square it now, all square. So that's what I'm going to use to compute my solution. Don't forget I have this already. I have x minus 10 to be 66, so this will be like 66 square, something like that. Okay, so okay, let's get started now. And don't forget that this is actually this variance, and it's given already here. Sorry, standard deviation. So the standard deviation is given, but we already know that where can I put that now? Let me just put it here. Let me put it. Sorry about that. How am I like this? Sorry about that. Let me just put it here. I'm just trying to manage my board. Okay, so don't forget that variance variance, let me use my sample variance. Okay, sample variance is actually your standard deviation. I don't know what I'm using, sigma for standard deviation. Should I use sd? Okay, sigma, guys, you guys are advanced level students, so you understand. Okay, so square, let me just write it in English, guys, so that you just understand. Because this is standard deviation, let me just use sd for you guys. So don't let me use statistical symbol, sd square. Don't forget this is variance, sample variance equals standard deviation square. So I have the standard deviation to be 4.5, so I can go ahead now. But the only thing is that I want to use this one as subject of formula, guys. This one as subject of formula. So I think I should write this one here first, right? If you don't mind. So let me just write summation x minus 10 all square, okay, over n equals to, now this one here, this is the variance and the standard deviation square. The standard deviation is 4.5, so that will be 4.5 square, guys. Hope I'm correct. 4.5 square. Okay, now this one here is minus, so when you move it here, it's going to give you plus. Okay, hope that is clear. So you have plus there. So now I have this estimate already, so it's not an estimate, I have this solution already, that is summation x minus 10. This is it here, summation x minus 10, and it is 66. Okay, so I have that already, so I can have 66 over 12. Okay, so that's 66. Okay, well, that is x minus, I have it already. Okay, 66, this one here, 66. Then over n, my n is what? My n is 12 over 12. Then all square. Okay, guys, I don't know, let me just go ahead and finish up now. So I will use this what I'm looking for, summation x minus 10 all square. I think the first thing is, let me just go ahead and use my calculator, because I'll just use this n to multiply whatever I have there. Okay, so let me just use my calculator now. 4.5 square plus 66 over 12 all square. So that is 101 over 2, so that is SD 50.5. If you don't mind, I can write 101 over 2 or 50.5. Okay, so this is 50.5. This one here gives sum up to 50.5, so n times that. So my n is 12, right? So that will be 12 into 50.5. 12 into 50.5. Guys, hope you are following this. This is pretty cool, right? Statistics is very interesting. Okay, so what's my final answer now? So 50.5 times 12, and that is 606. So the solution to the second question is 606. Okay, guys, this is the end of the first question, guys. Let's just go ahead to the next question. Okay, guys, this is the next question, and it reads, in a survey 55 students were asked to record to the nearest kilometer the total number of kilometers they traveled to school in a particular week. So the result are shown below. So you have the data ranges from 5 to 70. Okay, so there are 55 altogether. Okay, so 1 2 3 4 5, so mean that 11 11 observation on each row. Okay, so on the grid, draw a box and whisker plot to illustrate the diagram. Guys, hope you are familiar with how to draw box and whisker plots. We just go ahead and use the 5-number summary. Okay, so let's go ahead and use the 5-number summary. So what are 5-number summary? Guys, let me just put it here. 5-number summary, let me just put it here. So what are 5-number summary? So that the quarters, the minimum, and the maximum. So minimum, maximum, and the quarters. You know what the quarters are? Q1, Q2, Q3. Okay, so that's Q1, Q2, Q3. So when you represent this on something like can I call it like a rectangular rectangular bar. Okay, so that's box and whisker plot, and you indicate the mean value, the maximum value, q1, q2, q3. Don't forget that the q2 is median. Okay, and the q3 is also known as the upper quarter, the q1 is also known as the lower quarter. Okay, guys, let's go ahead and do that now. Let me go ahead and demarcate now. The first thing I'm going to do here is to let's go ahead and get the depth, that is the position, the data position for each one. So that will also known as depth in statistics. Okay, I look just like you say statistical okay, don't mind me. Okay, so let's go ahead and calculate the depth, that is the position. Okay, so for example, I don't have problem with the minimum, because minimum will be the least value in the given observation. Okay, so the minimum is definitely 5. We don't have problem with that. And the maximum will be the highest value there. So maximum, we don't need every formula to determine that. So that is 70. So let's go for Q1. Don't forget that Q1, which is the upper quarter, is also known as 25 percentile. Okay, I make video on this before, but that is additional mathematics. But this is advanced maths, English advanced A level. Okay, so Q1, don't forget from your previous knowledge, that is 25 percentile, and 25 percentile is 1 over 4. So 1 over 4, okay, into total observation plus 1, that is n plus 1. Okay, guys, we always use this n plus 1 in sample population, but if you look at your textbook, sometimes most of the textbook actually use n, and maybe for a good standard statistical textbook, I'm not saying they are not good and standard, and for sample for when you are dealing with sample, we use n plus 1, but when n is very large like population, then you can go with n, but everything is still cool. Okay, so it's an estimate value. So let's just go ahead with this one. Okay, so now this observation is 55. So 55 plus 1 will be 66. Okay, so 1 over 4 into 66, guys. Don't forget, let me just write n equals 2, so that now what is Aluko doing again? So I'll just replace n with 55. Anyway, you see n, put 55. Don't forget, these are not the actual value, but they are just the position. Okay, I'll count. So Q1, that is 56 divided by 4. 56 divided by 4, so that should give me the lower quarter position. So data position 14, that's what I'm going to take for my Q1. For example, minimum is data position 1, maximum is data position 55. So Q2, which is also known as the median, is 50 percentile. So 50 over 100, that is 1 over 2 of, I think at this time I can just go ahead and use you know the formula already, so into 56. Yeah, so this is video, so you are listening. I need not to write everything. Okay, so just listen to what I'm saying, guys. 56 divided by 2, so that is 28. So data position 28 will give me the median. Okay, 28. Then finally I need the upper quarter, that is Q3. Upper quarter is also known as the 75 percentile, and 75% is that is 3 over 4. So 3 over 4 into 56. So what is that? 3 over 4 into 56. So I need to use my calculator to compute that, guys. I'm sorry about that. I'm just lazy. I like, guys, it's good better to use your calculator when you're dealing with when you're working on statistics, so that in order to avoid unnecessary error, guys. Okay, so that is 42. So data position 42, guys. Please don't make mistake in your exams. These are known as depth or position. So you don't, this Q1 is not 14, it's just the data position 14. So let me go ahead and identify Q1, Q2, Q3. So I will count. I know that there are 55 altogether. 1, 2, 3, 4, 5, and there are 5 here. So meaning that on each row I have 11. So if you count it, this is 11 now. So going to 14, 11, 12, 13, 14. So this is data position 14. This one under 9. So let me just put it in rectangular box. So 11, 12, 13, 14. So this is data position 14. So this will be my Q1. Okay, then data position 28. Okay, this will be if this is this will be 22, because the 11 there's 22. I'm going to 28. 22, 23, 24, 25, 26, 27, 28. 28, the one under 19. So this is Q2. And data position 42. 42, this is 11, 22, 30, 11, 22, 33. I'm going to 40. So this will be 44. 44. So 44. So 42 should be, yeah, 50. Guys, hope you like the way I'm just trying to be smart. Okay, because I know there are 11 data: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11, 11, that will be 22. Another 11, that will be 33. So I just count. Okay, this will be 44. So I count back: 44, 43, 42. Okay, guys, it's good to be smart. Okay, so I know that this is my Q1, my Q2, and my Q3, guys. Hope that is clear. So let's work with that now. So now the best thing for me, because the examiner will like me to use the scale, and this is nearest kilometer. So let me choose my scale. So this is kilometer. So I want to know how many units. I'm not sure. I'll be careful to count these small boxes. It's to be too difficult for me, and I don't have the time. So I'll just go ahead and use my ruler. Okay. So this is kilometer. So this is the scale. So let me see. Let me go ahead and explore my tool. Yeah. So I need ruler, guys. Bring out ruler for me. Okay. So I'll work with this ruler now. So what I'm going to do is that I don't know. Um, okay. Before I use this, no. Let me just go ahead with my ruler because I just want to use it for scale. Can you just stay? I need to increase this one now. Okay, so I just want to see maybe how many units represent. So this is one. Okay. Okay, so I think this is pretty cool now. Let me see. This extends to 14. I don't know whether can I choose 15. I think everything here is 15. Okay, so this is pretty cool. What about if I use let me just go ahead and don't waste time. I don't need to talk too much. Can I just divide it into, since I have five numbers summary, five. Okay, so 15 divided by 5. 15 divided by 5. I think that would be the best for me. 3. Okay, so 3. So 15 divided by, so I can divide it though. So that's 3. So 15 divided by 5, that is 3. So for every 5, that would be 3. Okay, or should I just do 3? Let me just do 3. I'm sorry about that. Because 5 number summary, yes, that's 3. So I have 1 here. This is 3, 6, 9, 12, 15. So this can, provided they have yeah, something like this. So 30, 45. Okay, sorry about that. 45. That is 50, 65. 65 plus 15. So that is 80. Hope I did this very well. 45 plus 15 is what? 60. I'll say 65. Don't mind me. 60. Sorry about that. I can actually erase it. 60. So 60 plus 15 is 75. And I have 70, so it's okay. I think this is a perfect label. Sorry about it. I just like to take my time so that you see that I'm thinking the way you guys are thinking too. Okay. Okay, so guys, let's go for the minimum now. The minimum. Let me just use this line. So minimum should go to my minimum is 5. So 5. You can put this thing midway to count the number of, make sure that it's halfway. Okay, it's halfway. Make sure that it's halfway. I'm saying that. Okay, make sure that it's halfway. So 15. If this is 15, so this should be like 5. So this is 5. So this is my 5 now. Then I can go for my maximum. My maximum is 70. So this is 60. So 60 should be 70 should be between 65 and yes. So this should be something like 70 in between the two. Okay. So this is pretty cool. Then the next thing now, automatically this is my okay. Now the issue here is that 18 should be the 18 should be the lower quarter. So this shouldn't be, this should come here. So I don't know if I'll be able to erase this now. Okay, can I? Okay, I can't erase this. So what I'm going to do now is to, I need to clean this. I'm sorry about that. I need to take color white and clean this line here. Let me draw. I don't want this line here. Okay, this is a mistake. Okay, sorry about that. I need to clean this line here. So because it should be on 18. So it should be on 18. Okay, so I can put my 18 there now. So and then my, this one also I don't need this, so let me just take it off. So guys, here I'm taking my timer for box and whisker, but on normal day, you should be able to use your writing materials and effect this thing very fast. Okay, so let's go ahead and complete it now. So let me go ahead and take red back. I don't know, I think it's this color. Okay, so let's continue now. Now 18. So this should be 18. Like you can take how many boxes, something like that. So I need a line. So 18, that is lower quarter, Q1, 18. Then my upper quarter is 50. So 50, I still need to move this one back so that I can have 50 around here. So I will still take 50, should be around here. Then I still need to take white and clean that. Okay, sorry about that. Okay guys, I'm just taking my time for box and whisker. Oh, and why you wasting time on box and whisker? And this actually make you guys to understand better. Do you understand? So thank God for this mistake so that you know. Okay, so you draw the boxes such that the extreme values are okay. So that's pretty cool. Okay, so I can complete this task now. Everything is pretty cool. So you can extend this line here. Oh, I should have taken my red back. So you can go ahead and extend this line here now. Okay, let me do it again. Let me just take it from here. So you guys should have perfect diagram, right? Okay, so game over now. This one here is 18. So can I just write Q1? This is Q1. So your rectangular box should start from Q1 and end on Q3. Your rectangular box should start on Q1 and end on Q3. This is your minimum value and this is your maximum value. Then the next is your median now. The next is your median and my median is 25. So 25 should be in between 15 and 30, but should be closer to 30 compared to 15. Okay, it should be closer to 30 because it's 25. So let's put it here. In order to show that it's median, we can just make it a little bit deep somehow. Okay, so and this should be my Q2. My Q2. So if you want the examiner to understand what you are doing, you can go ahead and label. So this here is 18 and this here is 25, the value. The minimum is 5, the Q3 is 50, our maximum is 70. Okay guys, this is 5 marks. I think it's worth it, so we have to take our time. Okay guys, that's the end of this question. Now guys, let's go to the next question. Okay guys, here is the next question. An outlier is defined as any data value that is more than 1.5 times the interquartile range above the upper quarter, or more than 1.5 times the interquartile range below the lower quarter. So show there are no outliers. Okay guys, if you can recall from our last question, our last solution, and that's question 2, we have the minimum and maximum. So any value outside that, or let me say any value lower than the minimum, any data value lower than the minimum, which is 5, or let me say okay, any data value greater than the maximum, sorry about that, greater than the maximum, which is 70, based on the very last question, based on question 2, okay, will be regarded as an outlier. Okay, so let's go with the examiner instruction now guys. Okay, now an outlier is defined by this value which is more than 1.5 times the interquartile range above the upper quarter. So above means that plus. Okay, so meaning that guys, to be candid in statistics, let me just go ahead and give you the formula, but that is what the examiner is trying to explain here too. So now we have what we call fences. Okay, fences. So we have the upper and the lower fence. Okay, so now the upper fence I will use UF for that. Then the lower fence that I will use UP should be my upper fence. Okay, and LP will be my lower. Why UP? UF. Sorry about that. Since the fence. Okay, I want to use the first letter, and this will be the lower fence. Okay. So now, what is upper fence? So we can go back here now. So that is Q3 above the upper quarter. Upper quarter is Q3. Q3 more than, that is plus 1.5 times the interquarter. You know interquarter is Q3 minus Q1. That is the difference of the upper quarter and lower quarter. So that is upper fence. So that's also the um this that's we interpret this one now. So similarly the lower fence here too. Below the lower quarter, that is Q1. Okay. Then minus 1.5 into Q3 Q1. Q3 minus Q1. So we can go ahead and apply that now. So let's apply that. Okay, so guys, don't forget what is our upper quarter there from the last question. Don't let me use upper quarter, let me just use Q3. From the last question, the Q3 is 50, right? That is from question 2. Also we need Q1 from question 2. Q1 is 18. So let's go ahead and work with this now. Okay, so for the upper fence now, so we are going to have that is 50 plus 1.5 into the difference of Q3 and Q1. In order to manage my time, guys, Q3, sorry about Q3 is 50 minus 18. 50 minus 18. So that is 32. So that is 32. She's 32 here. Then the lower fence too. So that will be what? Q1. Q1 is 18. 18 minus, sorry about that. 18 minus 1.5 into 32. Now if they are out, 50 plus 1.5 into 32. So that is 98. And you can see that 98 is greater than 70. So that's condition 1. Okay. That, okay, meaning that they are out, that shows that there's probably show that there are no outliers. Okay. So 98 is not part of the data because this is the minimum 5 and this is the maximum 70. So since there is no data that is greater than 98, so that indicate that there no outlier there. Then let's go ahead and see the lower fence if there's any data in that range. So that is 18 minus 1.5 into 32. So and this is, and there is no data minimum, there is no data that is minus 30, so mean that there are no outlier. So for this we use fences to determine if they are outlier. So if you have a value like 98 as part of the data set we have above, or minus 30, so these are outliers. So we use upper fence and lower fence to calculate outlier. Now I can conclude that since 98, or better still, I can say I can calculate the maximum is 70, is less than 98. That is less than the upper fence, and the minimum, which is 5, is greater than, or should I just use greater here? Okay, let's just compare 98 instead of this. Let me make it in a bit. Let's do upper fence with let's make it, you can do it vice versa, but let's just do something like this. Let me write 98 first. Since they are fences, okay, so let's use so 78 is greater than, because 78 is regarded as an outlier, okay. So since 78 is greater than maximum, so meaning that the maximum is not an outlier, because 78 is greater than maximum, which is 98 is greater than maximum. 98, this 98 is greater than maximum, and also the minimum is less than the lower fence, which is minus 30. So we can conclude that there are no outlier, because 98 and minus 30 are regarded as outlier. And if you look at the data we have there, it ranges from 5 to 70. So any value below this is an outlier, and any value above 70 is an outlier. So since the given data set, the observation, the given data set, I think there are 55 altogether, so there is no value that is less than the based on computation to determine if they are outliers. So no value is greater than 98 and no value less than 30. So in conclusion, I can conclude that there are no outliers. There are no outliers. No outliers. Outliers are extreme values, guys. Okay, guys, this is the end of the question. Let's just go to the next question, guys. Let's go to the solution to the Cambridge Advanced Level Mathematics, May June 2018, paper 6-1 and probability and statistics 1 will be available on my YouTube channel immediately after this session. And guys, here is my YouTube channel. There are quite good numbers of maths, additional mathematics, ICT, robotic and coding video on my YouTube channel that will definitely help you guys enhance your learning. Okay, so you can just go through. If you find any of my video useful, just go ahead and click like, and you can also subscribe to my channel. We appreciate any of my work for subsequent updates of new videos. Also, here is my test shop, guys. You can have access to quite good numbers of board worksheets, e-learning resources, and all the videos available on my YouTube channel are also available via my test shop. So if you find any of my e-learning resources useful, guys, go ahead and you can help review and in order to see what I can do in order to improve on my resources, and you can also just go ahead and click like. Okay, guys, let's end with this note, guys. Guys, do have a great day ahead. Let's end with this note, guys.
Wake the streets up. Yeah. Yeah. Okay. Wake the streets up. Okay. Come on. Okay. Wake the streets